if the topic of greatest common factor or GCF ever felt very confusing, you are in the right place. We are going to figure out together how to do it without memorization, just simple algorithm that you will be able to use and you will not have to be worried about on the test how to do it. Okay, the first thing we need to understand is what are prime numbers. Now, prime numbers are like building blocks of all numbers. Just like imagine your body consists of atoms, right? So everything that we see has these little atoms that are building blocks. Same thing with prime numbers. Now, the definition of a prime number, it's a whole number that cannot be divided by anything else other than 1 and itself. For example, 2 can only be divided by 1 and 2 evenly, right? 3, same thing, can be divided by 1 and 3, nothing else. 4, well, no, 4 is not a prime number because it can be divided by 1, 2, and 4. But 5 is, okay, 5 is only 1 and 5. 7 is, 6 is not because it's 1, 2, 3, 6. 8 is not, 9 is not because 3 and 3. 10, no. 11, yes. 11, yes. Then 13, yes. Then 17 and 19. I do not think that you're going to need any more than that. Those are just the first few that you need. By the way, 1 itself is not a prime number because 1 only has itself as a factor, right? You cannot divide by anything else. So 1 is not. Okay, here is the first thing we're going to learn, and that is when you're trying to find the greatest common factor of numbers, you need to decompose them into primes. All right, so let's do that. Let's start with 10, and I'm going to show you the prime decomposition. Okay, first thing you're going to do is start thinking, okay, here is a list of prime numbers. What can I divide 10 by so that it divides evenly? And by the way, you can just use the Desmos calculator for that. 10 can it be divided by 2 and give you an integer? Yes, a whole number. Okay, so 2 and 5, those are the two prime numbers. Now, these are already primes, right? You cannot decompose them further, so you stop. Okay, this is the prime decomposition of 10. All right, so we got 2 and we got 5. All right, let's move on to the next number. That one is 35. Let's see. Okay, 35. Can you divide 35 evenly by 2? No. And again, if you are ever in doubt, you could just go here and see, okay, is it going to be divided? Do I get a decimal or do I get a whole number? I get a decimal, so it's not going to work. How about 3? It's not going to work. Remember, you have a calculator. Just do this. How about 5? Yes. 5, yes, and the answer is 7. Note how 5 and 7 are already prime numbers, so we stop. We're not going to move on from here. We already decomposed it. Next one is 25. Okay, again, to do the prime number decomposition, start with 25. Let's divide it by 2. Doesn't work. Divide it by 3. Doesn't work. Divide by 5. Yes. I can now see that it is going to be divided, and it's going to be 5 and 5. Okay? After you did this, all you need to do is look and see, is there a factor, or maybe factors, that these decompositions have in common? Well, 2 occurs, it's a factor of 10, but it's not a factor of 35 and 25, so it's not going to work. But 5, yes, 5 is here, 5 is here, 5 is here. That's it. That's all they share. Okay? I already know this is going to be 5. How about the x's? What do we do with that? Okay, so here's how you do that. You do not actually need to do any kind of decomposition, nothing like that. Look at x squared, which is actually x multiplied by x, and x cubed, which is x multiplied by x multiplied by x. What do they share, all three of them? Well, they only share one x, right? This is it. This is it. I want you to remember, out of 2 or more powers of x, so you have x to some power, whatever, you have x to some other power, and x to some other power, and however many terms you have, just take the smallest of the powers, and that would be your GCF. This x here is like x to the power 1. What is the smallest number between 1, 2, and 3? Well, 1. So that means that the GCF is going to be 5x. Let's check this.